Hi all, welcome to another edition of the Community Office Hours here at Open Rewrite and Madrid. As always, but not for the past couple of weeks, I'm Tim Bick, and with me is my co-host Sam Snyder.
Hello, everyone. Good to have you back, Tim.
Yeah, thanks. Cheers. I'm looking forward to being back for just a couple of weeks. No
Yeah,
travel.
you went to a bunch of different places. What's just like a quick bullet point list of like countries or cities that you've traveled through recently?
So we started 2 weeks ago at Spring IO, where I gave a presentation on how we use AI at Madrid. I
I
can
saw the
actually link
photos. The
something.
audience was packed.
It was a big room, yeah. So quite pleased with how that panned out. I'll be able to link the video as well in just a couple of moments. And then from there, I went to Portugal, where there's a conference in Coimbra, which I've never heard of, but it's a very nice town in the central in Portugal, and just a very nicely organized conference. With it's being held in like a 15th century former monastery, so that's
Oh,
a
cool.
quite a unique location for a conference. So
Yeah,
yeah, I had
best
a
place
lot
to
of fun.
discuss tech.
Yeah. So it's very nicely modernized and everything, and fully packed. I think there are 1,200 attendees, so that was pretty good. And then at both of those, I also gave a workshop that we have on writing open rewrite recipes. I think we've featured a bit, but I'll share the link as well once we get to the what's new in the past couple of weeks, as well as the video for the talk that I did at Spring IO. So, with that, I
Right.
think I'll take us through all the things that are new in the past week, and then after that we can take a more deep dive into the topic that you've prepared. So new as of this past week is that we did a new release. So if you're curious to see all that's been worked on in the past 2 weeks or so, then you can check out this rewrite recipe 1 release and the links out to the individual plugins for Maven and Graven and the Open Rewrite. So that's available as of last Friday. There's a couple bug fixes in there which were affecting folks parsing YAML files or doing recipes for Spring migrations. So be sure to be on the latest version such that you don't get run into those bugs, and I don't have to point you to the latest versions to get those fixed. As part of that new release, we also updated our docs quite a bit. So before we didn't quite feature recipes that are maintained by our friends and are bundled up in the rewrite third-party library. But now if you go to docs.openrewrite.org, you can actually see all the recipes that are being maintained by our friends at Picnic and our friends at Apache Wicked, at Axon Framework, even the recipes for Timefold and Quarkus. Those are all now also available through the docs.openrewrite.org. So if you want to see all the recipes that we have available there, then just follow the link that I just shared in the chat. And then from there, you're able to see all these individual recipes that are just being maintained outside of the Open Rewrite org, but are still going to be available for you to run. And it's a neat bunch. And in particular, it's interesting to see the testng recipes available in there, because we have quite some interest in the community on doing recipes for testng specifically. We're working on a video showing you how you can migrate from Hamcrest and JUnit to AssertJ, but we also have folks interested in going from testng to AssertJ. And I think we have 4 parallel efforts to help folks make that move from testng to JUnit and AssertJ as well. So pretty neat to see what's coming up there as well. And then just to reiterate, we also are doing a time-limited giving away the CLI and the Modern IntelliJ plugin for until the end of next month. So if you want to see all the neat things that you saw maybe on the last week's edition or the week before that, you can fill out this form. If you go to there's a shorter link which we just shared in chat as well, where you can just get access to the Modern IntelliJ plugin, the Modern CLI, to do everything you want for the next 6 or so weeks still. So be sure to check it out. It's going to be a very handy thing to do and maybe pick up and fix some issues for the next couple of weeks, and then from there see if you want to explore Modern further. Then there's also some events coming up. First up, on July 16th and 17th, there's going to be we're going to be at UberConf. We're going to be there with a couple of different sessions. If you look, you'll see that the top three here are actually our colleagues here at Moodle. And then Jonathan is doing no less than 4 different sessions there. So if you want to see his talk on automated software refactoring with open rewrite and generative AI together with Justine, then that session is coming up there. We're also the half-day workshop on the fundamentals of migration engineering with open rewrite. And I believe a keynote presentation on the rise of the 100x developer is that you can see over there. So be sure to check it out if you're nearby. Then yeah, you can learn all about the things new at Moodle. And I think that software development should be done. I will be there. I will be at a different conference. We are Developers World Congress in Berlin, which is a quite a sizable conference. There's some 15,000 folks attending. And you can see that from the size of the room. So there's some, if I read this correctly, some 5,000 folks that can watch the main stage. And I'll be on a slightly smaller stage where only some 500 folks can watch me tell the folks how you can do broad sweeping changes across a number of different repositories. Of course, with the tooling that we offer here at Madrid. And then that's the 2 events that we're looking forward to. But apart from that, we also had a new video going last week, which is this one, where voiced by our very own Kevin on how you can make sure that you are developing software that is a joy to work with, such that it's easier to attract and retain talent. Because yeah, no one wants to spend their career patching security holes and manually doing framework migrations. So really use the tools that we have to actually make a difference there. Now, as I told you, the video that I did at Spring.io is already online. So if you want to see me present on exactly what it is that we do with AI at Moodle, then you can have a look there. And it also gives credit to Justine, who has done all the hard work on this presentation. And I'll be sharing the link in the chat here as well. So that's already up. And it was a lot of fun to see the response that got. And then, as I said, I also gave a workshop to some lucky folks present at the conference, which you can access through the URL that is now in the chat as well. So that's pretty much everything that's new over the past couple of weeks. And of course, we'll be expanding this. There's already some new videos in the pipeline and some new blog posts that we hope to share with you next week. But for this week, we're going to dive into a more technical topic. When Sam, I think this is the moment that I hand it over to you.
Yeah, right on, Tim. Thanks a lot. So, in my capacity of teaching our customers and our open source community how to author recipes, I occasionally run into some of the same mistakes being made, particularly by new recipe authors, over and over again. And I've collected a list of conventions and best practices and pitfalls to avoid in this recipe conventions and best practices document in our documentation. And today I want to focus on 2 of those, which are which most recently caught my attention, um, around both of them kind of around immutability and avoiding manipulating state, uh, avoiding manipulating state where no state manipulation should take place. Uh, and you know, if you follow our examples, it may never, or in what's already checked in open source, it may never occur to you that you might run across some of these mistakes. But I want to point out that like recipes should be themselves should be idempotent and immutable. If you find yourself storing, like visiting a source file and storing state on a field in a recipe, you're probably doing it wrong, right? Most of the time, if you are sharing state between from one LST to another LST in the same repository, or part of the same recipe run, there probably needs to be a scanning recipe, which is a topic we've talked about before, and I'm sure we'll talk about again in the future. But even more, maybe more common or perhaps more pernicious than a recipe not being the recipe not being immutable is that the LSTs themselves should never be mutated. LSTs are mostly immutable by default, right? You won't find set methods for the fields on an LST anywhere, and that's intentional and deliberate. And this allows us to be very memory efficient with the LST representation, and it allows us to very easily and quickly detect changes from one LST to another. Now that might sound kind of paradoxical. How do you detect change in something that is immutable, not allowed to be mutated? The obviously the answer is with referential equality, right? The framework detects that a recipe has changed in LST not because the LST itself has been mutated, but because a different LST came out than went in. And in support of this, all of the Open Rewrite APIs and all of the method calls on LSTs themselves um, have these kind of immutable data access patterns by default. But there is one hole in these protections. There's one like glaring place where someone could naively and unintentionally stumble into causing their recipe to not work correctly, and that is with any LST element that has a collection on it. Typically, a list, like the argument list on a method declaration, is an example. The lists, the field that list is assigned to is final, so you can't modify that. But the list itself isn't read only. It is still a mutable array list. Maybe that's something we'll change at some point because this mistake is unfortunate. But if you were ever like get an argument list of a method invocation and try to remove an argument from it by just removing an entry from that list, like you have messed up potentially badly, right? This because the reference to that argument list didn't change. Open rewrite won't detect a change at all, and you may or may not see that change reflected in the final diff. Um, and this is unfortunately easy to do. So I both wanted to remind our viewers of this best practice and try to practice what I preach a little bit in terms of encoding your best practices into recipes so that you don't have to do what I'm doing right now and just stand up and say, hey, reminder everyone, don't do this thing that causes a problem, because you never reach 100% throughput to current and future audiences just by having a best practices document and reminding people about it occasionally. Some people will forget, people will not listen, new people will join long after the presentation is in a dusty archive. And so, in support of this, I've cooked up a recipe which I haven't added to any of our GitHub actions, our automatic PR reviews yet. Could talk to Tim about that after, but I have added this recipe to Rewrite Recipe Starter. Uh, and so this is already checked in React Recipe Starter. Regular watchers of our channel are probably familiar with this as our example recipe module, and increasingly it is a source of documentation, or rather examples, samples of recipes that take advantage of different and interesting parts of the API. And so the one I've added here is this no collection mutation recipe, which I have open in my IDE here. And as ever, when looking at a new piece of code, the place I go to understand what it does is its unit tests. And so what we see in the unit tests is that when getting like the argument list of a function or other collections types and invoking methods off them that are non-mutating, that are just querying information from the collection, the recipe should leave those alone. But if a mutation is happening, then wrap it in a defensive copy with a new array list constructor and avoid, prevent the original collection from being modified. And I'm not totally done with this recipe yet. I think I might augment it so that it also includes an explanatory comment, likely with a link to the relevant section of the documentation. Since, even after the recipe has run, like, in this example, clearly the author was intending to mutate the methods, was intending to change the arguments on the method. And just by preventing this mistake, well, the recipe still doesn't, this in this example, this still wouldn't do what the author of this of this visitor wanted it to do, which was, clear the argument list of this method invocation. So I think this is one of those situations where automation and recipes could get you part of the way, like it could detect the infraction and it could bring it to someone's attention and point them to the best practice, but it might not be able to fully automatically remediate and fix every permutation of this mistake. So, how does this recipe, work? And even in maybe more advanced cases where this one is not too hard to detect. If you're familiar with basic recipe authoring, you're like, okay, I could look and see, off of get arguments or a collection returning method like that, I could look and see if a mutating method was chained directly off it, but often they are not. Often the mutation happens later in the function, right? And possibly inside an if statement or conditional or some other control flow structure. So how do we write a recipe that detects and fixes this case, that notices that well after method.get arguments is queried and stored in a variable, that variable is mutated, and then go back and put a defensive copy around this? Well, that's a difficult thing to do, at least until you bring in the data flow analysis capabilities that were, I think, originally contributed to Open Rewrite by Jonathan Lightshoe, a security researcher we've worked with in the past. And so I wanted to include an example. Yes, and you have to take a dependency on this rewrite analysis project to get access to the data flow analysis type stuff. So I wanted to add an example to the sample repo, which would both teach people about this important best practice in recipe authoring and demonstrate the data flow analysis capabilities that are available within the framework. Get markers. Okay, Jinte has a question that is pertinent about whether, say, you had a variable and you manipulated the markers and you got the original markers and you mutated to it. So let's see. So if we go and look at the markers object, and this is a good question. So you'll see what the add method does on markers. So Jinte's question is, what if markers are optional metadata that's attached to an LST element? What if you use this markers.add method? And you'll see that inside of markers.add, it does perform a defensive copy only if the marker you're trying to add isn't already present, and returns a new markers instance. So the example you asked about where you said variable with markers, variable get markers dot add, this is totally fine and okay. This causes no problems, and it causes no problems specifically because this add method is part of our framework, and it is aware of the importance of referential equality and of doing a defensive copy as appropriate. So you're totally fine to do this, Jinte. This is a good and recommended way of manipulating the markers on an LST element. But good question. Okay, so back to the recipe. So the recipe itself, that is now included in Rewrite Recipe Starter, both kind of exists as documentation for anyone who clones this, that this best practice exists. So just hopefully another place they will notice and step onto it, and demonstrates how to use data flow analysis to detect that some of these changes have happened. Tim, have you ever messed with data flow analysis, either in the context of Open Rewrite or anywhere else?
I've used it. So that's not a very high bar of having used it, but I've used it when we used the recipes for launch darkly feature flag, where you
Right.
might
Yeah.
want to find like is this key enabled or not, but that key
Right.
might be a variable or a field or a
Right.
constant somewhere hidden away,
Hmm.
and you still want to find the feature flag toggle that's being set. And then, of course, this is perfect to help you locate where it's set and help inform if the first argument is the key you're looking for.
Absolutely. Yeah, so I also don't have I've never, formally studied data flow analysis. There's lots about it that can go over my head, and I mostly figured out how to use it from looking at other examples of it being used and trying stuff out until it works. So if there are any data flow analysis experts in the audience, and I do make a mistake with my terminology or my explanation of that terminology, I welcome you to post a correction and to teach us all. Okay, so in the implementation of this no collection mutation recipe, I do the kind of typical stuff, the defensive stuff, to avoid mutating or even just avoid performing an expensive data flow analysis computation on method invocations that are irrelevant. So, specifically, the method invocations I'm concerned with are methods on a type that extends from org.openrewrite.tree. This is the root of the LST type hierarchy. Every LST type extends from tree in some capacity. It's an interface. Every LST element implements tree. And on any methods on any type that implements tree, which return a list, it's potentially problematic to mutate that list. And so, at the point where we start to invoke the data flow analysis capabilities, we have already narrowed it down to our starting point is a method on a tree that returns a list. And you initiate a data flow analysis with this data flow starting at method, which, as Tim posted earlier, is defined in the rewrite analysis module. And the rewrite analysis module is one that under the org.openrewrite.meta namespace. So if you'll need this dependency in there in order to take advantage of this capability. It's not in rewrite core. But once you've taken that dependency, you can invoke data flow starting at and pass in a cursor to provide the kind of starting point for the data flow analysis. And then there's kind of two terms that are important here, or I guess three terms. There's a source and a sink. A source is someplace that data kind of enters the scope, an origin for some piece of data that you want to analyze. And a sink is someplace where that data goes, that it flows to. So, the source of a list, might be, in our case, the source is, method declaration that get arguments, right, is the source. We've already identified that, so we're saying source is true, and we're specifically looking for sinks, places that source flows to through all possible paths of control flow, at least all paths that are local to a particular function. We're looking for sinks that involve a list mutation. So, this function, it just checks like, hey, is the sink is the place or are the places that this function the data returned from this function ends up, are any of them in the select of a method invocation of any of these methods from list that mutate, add all, clear, remove, replace, set, sort. Is does this so does this so this checks essentially, does this method invocation that we are coming from this cursor ever end up through any control flow path, does it ever end up having a mutation method called on it? So this bit will find all of the potentially many different paths that this data might take through the control flow of your program. So, in a program like this, the source is going to be method.get arguments, and that goes into args. and then args goes into this is empty call, and it goes both, and there's kind of two paths through here. One path, it does enter the if statement and does have a mutation done, and in the other code path, represented by the invisible else branch, it does not go into that if statement, and there is no mutation. In this case, any mutation along any path that this data takes through the program should result in the original method having a defensive copy placed around it, or, as I finish this recipe, a comment added to it. And so, I want to, with this bind function, look at all of the paths that this takes through, this data takes through the program, and if any of them are, you know don't contain a defensive copy, then we need to add a defensive copy. So it would be fine not to have a defensive copy around method.getArguments if, there were already a defensive copy, down here. This isn't what I'm expecting the recipe to produce, but this would be fine, right? This would not require the defensive copy up here to be added. So that's what that is trying to do in that part of the recipe. And so this is, if we find any one of the kind of paths that this could take through the code where it is not in a defensive copy, then we say, yes, this is a relevant sync. This is one we care about. And if we don't find any paths that end in a mutation, we're like, nope, we haven't found anything, and no mutation to this list occurs, so we can return early with no further changes. And so only if we both find a method here and find it being mutated do we then determine that it is necessary to use our familiar Java template manipulation in order to wrap our original method invocation in the new array list constructor. So this is pretty cool and powerful, but it does have some limitations. It is possible to fool this. This is local data flow analysis, so it can only really like track you through the kind of the lexical scope you were already in. Like if the mutation happened in some other function, it would not be able to follow that this function that this other function performs some mutation. And if the method goes into um, or if the data of interest goes into a method that is not known to the recipe, like this remove first method that I added right here, it doesn't, the data flow analysis in the recipe can't, doesn't know what this remove first method is going to do. And in this case, it's in source code, so it might be obvious to a reader that this is what this does, and the name certainly suggests that's what it does. But just as often, this method might be in a binary dependency of some kind, and we would have to do like bytecode analysis, which isn't impossible. It's just a bunch of additional work to implement that kind of thing. So as you use these capabilities, be aware of their limitations, right? It would be really cool if our data flow analysis capabilities could look at this and go into remove first and realize that method.getArguments is going into remove first and being mutated there and add the defensive copy, but it doesn't, so it can't. So if you find yourself in a situation like this, uh, that's difficult. That's difficult. So yeah, local data flow analysis is powerful, but its power is not unlimited. And I'm sure we will add more and more powerful data flow analysis capabilities over time. But this is kind of where we're at right now. So yeah, so that is kind of our recipe, and yeah, I think I will continue to not only do the defensive copy, but put a comment with the link to the docs page here, so that people running this recipe will know what to do about it when they see this. So yeah, this is in React Recipe Starter right now. So if you've ever had a problem where you were like, okay, I want to see how this variable is used. I want to know what happens to this variable, or I want to know where this variable, or method invocation, where this comes from. So you can kind of look forward or backwards. Like you can start with the source and look for its sinks, or you could start with the sink and look for its sources. And this can be relevant for security recipes frequently. Like, hey, we have the constructor of something that serializes and deserializes YAML. Does it have the set safe true method called on it, for example? Hey, we're doing some HTTP communication. Does this is the REST template? Does it have set CSRF protection enabled true set on it? These are scenarios where local data flow analysis is really helpful because the origin of the question and the answer to it are proximate, right? They're not the same statement, they're not the same method invocation, but they're probably right after the other, right? It's probably they're probably very nearby, and local data flow analysis is perfect for those situations.
I
Yeah,
can think of another case.
yeah,
If you're going to do a query, you might be interested in how that query is built up, like a SQL
yes,
query. And then data flow analysis is perfect to figure out if you were doing some concatenations just before that, and if the concatenation
yeah,
variables coming in are maybe from a source that you haven't verified. So it's another
yeah.
use case of potential recipes to explore.
Yeah, absolutely. Yeah, you could look for uh is this method parameter validated, right? Like is there a null check for this method parameter? Could do things like notice that a method parameter is annotated with nullable, but then nothing actually checks that parameter isn't, or a method parameter is annotated with non-null, but nothing actually checks that the value is non-null, or something along those lines. Yeah. So yeah, good stuff. Um, yeah, so see, I think that's all I have to say about this recipe, unless there are any other uh, questions. So yeah, I encourage you guys to be aware that those capabilities exist and to take advantage of them in your recipes. And don't mutate LST element collections. Don't do it. It's a bad idea. You're just going to hurt yourself. I'm sorry that there is that jagged edge within the API that you can prick your finger on and inadvertently cause yourself pain. I did once try to go in and wrap all of the collections in an unmodifiable list, and it caused a bunch of problems, particularly around the detection of, well, actually the detection of referential equality, or using referential equality to detect changes. Uh, it got tripped up by that, and at least at the time, I decided it wasn't worth the trouble to pursue further. But we could always revisit that in the future.
Yeah, and of course, the one with the recipe is going to be fit for use in our automated enforcement. You will see those comments appear on your pull requests when you contribute something back to us, or
Yeah,
similarly if you add those to your own recipe libraries as well.
yeah,
Look forward to that. Just one
yeah,
less
absolutely,
thing to think about when reviewing PRs.
exactly. Exactly. Yeah.
Mhm.
So if I yeah, looking through this list of best practices that I put together, yeah, we already have recipes for some of these things, and as we have recipes for more of them, it kind of takes a code reviewing burden off of me and off of other people who review these things. So as the maintainer of a library, or as the maintainer of any piece of code, you can use this to save yourself work, right? As software engineers, we're professional automators, so let's automate some of our own busy work while we're at it.
Yes, absolutely. And I hear that from friends in the community as well, that they're looking for similar automations for their own projects. And
Totally.
I hope to have some news soon about how we are integrating these types of checks in other open source projects as well. So,
Yeah,
yeah.
right on. So I think that's all
Then,
I have for today. Any closing remarks, Tim, or anything else you want to add or talk about?
yeah, I think like we can look ahead to next week, where we hope to have Kyle on to take a look at the new builder that we're working on the app.modern.io, so the modern platform side of things. We're gonna look to make it easier to modify the large recipe, composite recipes that we offer there, because
Hmm.
we found that once in a while, we'll have folks that maybe want to add some steps to a composite recipe. So if you have your own internal framework building on top of Spring, you might need to migrate that starter that you have as well, or your internal libraries, alongside a larger composite. And then the builder is our answer into making that very easy to do. And it's free to use for everyone. So just go to app.modern.io and you can already explore it. And next week, we're going to dive deep both into how you can use this and how we have built this. So look forward to that.
Yeah, it'll be
And
fun.
then, yeah. And then finally, a quick reminder, do have a look at that CLI and the plugin that we have. You can scan this QR code or go to the bit.ly link in the bottom. And from there, you can see exactly how you can access the license that we have to run the Modern CLI and its other plugin for the next couple. So that's it. Then thank you all for coming, and then hope to see you all next week.
All right. Thanks a lot, everyone.
Cheers.
Bye.